I welcome you all to the session of engine system and performance. Today we shall discuss an important topic of this course, that is energy transfer mechanism. We all know that in an engine, essentially what we need to do, or rather what we do is, we need to supply fuel, and fuel is having chemical energy stored within it, and that chemical energy is converted to some useful work which is available at the shaft. Now, this conversion of chemical energy which is remaining stored in the fuel has to be converted into another form, that is work, another form of energy, but this conversion is not directly possible. That is what we have learned. So, what we do is, we need to supply fuel air mixture if it is a SI engine. If the engine is of compression ignition type, then we need to supply fuel and air separately. Whatever may be the case, in both cases this fuel and air mixture, rather they mix together and then combustion occurs, and because of this combustion we get some heat energy, and then that heat energy is converted into work. That conversion is not very efficient, that we know that heat is low grade energy and work is high grade energy, that we have studied in our basic thermodynamics course. So, what we need to discuss today is that mechanism by how that chemical energy which is remaining stored in the fuel will be converted into work, and that work should be available at the shaft, and then only we can propel the vehicle. So, if I write that fuel which is having chemical energy, that fuel should be converted into work, should be available at the shaft. So, this conversion is not directly possible. So, that means what is done essentially, this fuel is mixed with air and then there will be combustion, and out of this combustion we will be getting heat. So, another form of energy. Right, and then that heat is essentially converted to work through certain mechanism. So, this is essentially the energy conversion or energy transport mechanism, right. Now, question is that the energy that we are supplying to the engine or to an engine, out of the energy, if we assume that that is 100%, 30% of that energy is lost through enthalpy, or rather in terms of enthalpy and chemical energy. So, this is very important to know that if I write here %30% of the stored energy. So, this is chemical energy, let me write here stored. Now, this 30% of stored energy leaves from engine in the form of enthalpy and chemical energy. So, this is something not in the positive side, because if the stored energy is 100%, if we assume, then 30% of that stored energy lives or will live from the engine in the form of enthalpy and chemical energy. That means, this energy is not available, and if it is not available, then certainly efficiency would be less than 100%, there is no doubt about it, but is that only 30% energy will live in the form of enthalpy and available energy? Is this 30% is the only energy that will live in the form of enthalpy and chemical energy from the engine? So, let us look into that part. You know that question is, this is not only the energy that will live from the engine in the form of enthalpy and chemical energy. Typically, rise in temperature in the combustion chamber because of the combustion is of the order of 3000 Kelvin. So, let me write here temperature rise in the combustion chamber of the order of 3000 Kelvin. Try to understand, if there is no any mechanism, no any avenue to transfer this much amount of, if there is no any way out to reduce the temperature of the combustion chamber, certainly it is very unlikely to have any material that would be able to withstand this high temperature. So, there must be some mechanism to transport or to remove temperature or to reduce temperature of the combustion chamber, so as to prevent combustion chamber cylinder from their melting and many other problematic issues, many other detrimental effects. So, temperature has to be reduced, temperature of the combustion chamber. So, certain heat removal management, thermal management of heat must be there in an engine. Now, question is, we have to remove heat, right, that is available in the combustion chamber. Now, we can remove heat through certain surfaces, through some surfaces rather. What are those surfaces through which we can really remove certain amount of heat? Otherwise, the temperature which is available inside the combustion chamber will lead to several mechanical failures. So, let me write here, which is very important to know at this time, that places which are exposed to high temperature are spark plug, right, exhaust valve, which is very important to know, intake piston face and also to some extent intake manifold, right. Now, so that means these are also the places wherein temperature will be high because of this temperature rise. So, can we really remove heat through these surfaces? No, we really cannot, because these surfaces are so very I should say complex arrangement. So, these surfaces are integrated to an engine block through some complex position. We really cannot have any supply of coolant, so that we can remove heat from these surfaces. So, that means these surfaces are having very high temperature, and removing heat through these surfaces is not so easy because of lack of integration of cooling system. So, then let us briefly discuss about the energy transport or rough estimate of energy transport, what is the total amount of energy, and then the possible surfaces through which we can have thermal transport of heat, so as to prevent engine from their engine cylinder and several other components like spark plug, exhaust valve and piston face, which is very important, rather very critical part of the engine exposed to a very high temperature. So, now we shall discuss about a rough estimate of the engine energy available inside the engine. So, we shall discuss about energy distribution. So, to know that, let us discuss about the amount of energy available with the fuel, how much of that energy is available at the shaft, remaining energy has to be transported or transferred from the engine cylinder or from the combustion chamber into the ambience through certain surfaces. Mind it, spark plug, exhaust valve, piston face and also to some extent intake manifold, these are the surfaces wherein temperature is or hot surfaces rather, temperature is maximum, but unfortunately it is not so easy to remove heat through those surfaces. So, we have to know what are those surfaces through which heat removal is possible effectively. So, if we write here just available energy that is in the engine is mass flow rate of fuel, heating value of fuel. So, this is heating value of fuel and this is mass flow rate of fuel. Okay. So, this is the total amount of energy available. So, if we supply this much amount of fuel to the engine, we are supposed to get this much amount of energy, which is in the form of chemical energy or stored energy in the fuel. Now, question is what is the amount of energy? So, out of this total energy, right, useful work, useful energy which is in the form of work certainly available at the shaft is how much? This is essentially we can write brake thermal efficiency into mass flow rate of fuel, heating value of fuel into combustion efficiency. This you know probably from your undergraduate IC engine course. So, that means try to understand. So, this is the amount of energy we are going to supply. Now, this if we try to recall, we have discussed already that this is the amount of energy we are supplying with the fuel, and this conversion is not directly possible. So, we had seen, rather we have studied in our undergraduate course, combustion will be there. Now, combustion, any mechanical process cannot have 100% efficiency. So, this combustion efficiency will be there. So, that is why you have multiplied with this. So, this is combustion efficiency, right. So, though we are supplying this much amount of energy, because of the combustion we will be getting this much amount of energy available in the inside the cylinder rather. So, this is inside the cylinder, right. This is with the fuel, and finally, we will be getting this is what is available at the shaft. So, this is brake thermal efficiency. Okay. So, this is the amount of energy which we are getting at the shaft. So, that means, if we write one step further, we can tell that m dot f q h v minus eta b eta c m dot f q h v. So, this is the energy which is not available. So, this much energy is not available, right. This figure includes, so that means this much of energy is not available, that means this much energy will be lost through heat losses, parasitic load, right, and energy that lost through exhaust gases. Okay. So, this is the figure. Now, so that means these are the losses, right, not available. So, let me quickly write. If we now write this expression in a bit different way, total total power generated equal to W dot shaft which is available plus which is not available plus W dot not available, right. So, this not available includes what? Q dot loss plus Q dot loss through exhaust gases plus W dot parasitic, right. Now, so this is loss of energy that we shall discuss now. This is loss of energy through exhaust gases, and this is loss of energy through conduction, convection, radiation from the engine cylinder into the ambience. This is the loss of energy which is in the form of enthalpy and chemical energy through the exhaust gases. Rather, yes, exhaust gases will leave from the engine cylinder and there will be some loss of energy in the form of enthalpy and chemical energy, and certainly some part of this energy would be utilized to run several units of an engine. If it is a luxury car or any other system, there will be several parasitic loads to run a small pump, to run several lights, to run an air conditioning unit, so many things. So, parasitic load is there. Let me tell you one thing, just one part I would like to highlight. This loss of energy through exhaust gases is even sometimes higher than the brake power or the shaft power. So, this is the shaft work which is available. The loss of energy through exhaust gases is sometimes even higher than or equal to that of the shaft power, that you should remember. Now, as I told you this that this loss is mainly through conduction, convection, radiation, because this amount has to be lost, otherwise we will not be able to save engine cylinder, piston faces or even piston for a longer period, because several mechanical or problematic issues will arise. Okay. So, if we now look at this quantity Q dot loss equal to, so this is basically that energy that lost through cylinder walls into the ambience. Now, this has Q dot coolant plus Q dot oil plus Q dot ambience. So, as I said you, this energy that lost through cylinder walls into the ambience through the cooling system and through oil circulation. We shall discuss all this thing. Now, what about this? So, this is basically 10 to 30%, Q oil is very small 5 to 15% and Q ambient is 2 to 10%. Okay. So, this is the classification. So, now we have come to a point that there are certain places, surfaces through which this loss of energy should occur or should take place. I mean, it has to be. We must design in such a way that this much amount of energy should be lost, should be transferred, so as to keep the cylinder or several other components of engine block from melting and other possible failures. Okay. So, this is what is important to know. Now, question is, we know cooling system, if it is air cooled engine, then extended surface would be there through which we can have continuous supply of air. As such, forward movement of the vehicle will allow to suck certain amount of air to be directed into that place, that surface, extended surfaces rather. If it is a water cooled engine, certainly we need to supply coolant water with some antifreezing reagent, and that coolant will, the circulation of coolant mass flow rate would be designed accordingly so as to remove certain amount of heat from the cylinder outer wall. And also it is not a case that all part of the engine cylinder would be surrounded by the cooling water jacket. So, some other exposed surfaces of the engine cylinder through which certain amount can be transferred to the ambience directly. So, this is basically the quantification. Now, let us, that means exhaust, if we look at that this shaft work is available work, this which is not available is having three components, Q dot loss through exhaust gases and W parasitic. As such, we really cannot have, we have no any requirement to remove this, because this is needed to run several auxiliary units. This is automatic, because we need to remove exhaust gases from the combustion chamber. So, when combustion gases are leaving from the engine cylinder, combustion gases will carry certain enthalpy and also chemical energy with them. So, this loss is also inevitable. Now, this loss is very important, that is what we have focused on, and we have to keep in mind that this some arrangement should be there so as to have this much amount of energy loss from the combustion chamber through cylinder walls, so that possible mechanical failure of several components of engine can be prevented. So, one such, and then Q dot loss has three components, that is what we have now discussed. Coolant, that in cooling system will be there. Oil circulation is done, because you know that we have discussed, if you can recall correctly, when we have discussed about engine block. So, oil pan is there, from that oil pan oil is, some splashing system would be there, so that oil can be splashed over the piston face, and while oil is splashing over the piston face, that oil should carry certain amount of energy or certain amount of heat from the piston face. We have discussed today that piston face is one of the heated surfaces, and as I told you that it is not a case that entire engine block or engine cylinder would be having extended surface outside, or cooling water jacket will occupy the entire outer periphery of the engine block or engine cylinder. So, some part would be there through which certain amount of energy would be transferred from the combustion chamber through the cylinder wall into the ambience, and that is 2 to 10%. So, let us briefly discuss about heat transfer or energy transfer in the form of heat, from an engine, right. At least let us discuss today. We have understood that we have discussed today certain amount of energy has to be transferred from the combustion chamber or engine cylinder into the ambience, and the possible mode of energy transfer, rather possible modes of energy transfer are the conduction, convection and radiation. In principal modes, these three principal modes are there. Most important modes are conduction and convection. Conduction will be there, because that through engine cylinder wall conduction heat transfer would be there, and then inside the combustion chamber some convective transport of heat would be there from the gases into the inner wall, and from the outer wall into the ambience again convective heat transfer will be there. So, these modes are important. Now, as I told you that though spark plug, exhaust valve or exhaust port and also the piston face, to some extent intake manifold, these places are having maximum temperature or the heated surfaces, it is not so easy to remove heat through those surfaces. So, even then we need to know what are the surfaces rather through which energy transfer or heat transfer takes place. Let me write here, one is heat transfer through heat transferred, let me write not through, in intake system or manifold, right. Number 2 is heat transfer in the combustion chamber. Number 3 is heat transfer through exhaust gases. I should not write exhaust gases, rather I should write, because exhaust gases is also having some part. Let me write in exhaust system or port. Okay. So, these are the 3 important surfaces through which we can have heat removal from the combustion chamber into the ambience, so as to keep several components intact, so as to prevent several components from their possible mechanical failure and to enable the engine to run smoothly. Now, question is heat transfer in the intake system, heat transfer in the exhaust system. We have discussed that intake system is to some extent, but exhaust system is rather exhaust is not so easy to remove or to transport heat through the exhaust system, because it is not possible to have any cooling system. Mostly you have to rely on the conduction and certainly some convection from the outer surface of the exhaust manifold into the ambience. In intake system also, but we shall discuss about several other possibilities by which it is really possible to transport certain amount of heat from the combustion chamber. Certainly, you can understand that heat transfer in the combustion chamber is only the way, because we can have cooling water cooling system, so as to remove certain amount of heat, even if the entire outer surface of the engine cylinder is not surrounded by the cooling system. From those parts also some amount of heat will be transported into the ambience. We shall discuss all these cases in detail. Together with we shall try to solve a few numerical problems, and we shall take up this part in the next class. With this I stop here today. Thank you.